The Leave plan of room specialists has tracked down that using our new $10 billion toy, it will be a very long time before that undertaking transforms into a reality. On the remote possibility that it goes as arranged, the trip to Proxima B will take around 20 years. So sensibly, it will be quite a few years before we can confirm if there is, to be certain, life on that planet. The deep-rooted question of whether we are truly alone in this universe perseveres. The James Webb Telescope has discovered some shockingly human-esque things far away from Earth that lead us closer to an answer. Our mission for life outside of Earth has been uncontrolled throughout every human civilization, to such a degree that we have a considerable number of media works and speculations regarding this matter. Our wonder concerning our place and loneliness in the universe has been consistent, as though it is ingrained within us to search for a companion continually, regardless of how untouchable they might be. We might be getting progressively closer to the answers we seek. However, are they really the answers we are looking for, or are they simply more frightening? Join us as we explore the most recent discoveries in the realms of systems and planets on the journey to find something we might not be prepared to witness. Lights far off, scientists have found what could be the most groundbreaking discovery in history. Back in 2021, when the James Webb Space Telescope was planned for launch, a very fascinating hypothetical question was raised about the capacities of our technology. The inquiry was whether, in the future, our telescopes could detect artificial light on another planet, for example, Proxima B, the closest exoplanet to Earth. Proxima B, around 4.25 light-years away, was thought to be tidally locked, with a permanent day side and night side, similar to our moon. A hypothetical technological advancement on Proxima B could involve transferring energy from the day side to the night side using photovoltaic cells that generate power from starlight. In a paper with Manasvi Lingam as one of the researchers, it was shown that large-scale solar coverage of the day side could be detectable by future telescopes. Since JWST was more advanced, it would allow us to extend our search for artificial lights on potentially habitable exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did exactly that in 2024, using its higher sensitivity and greater range of capabilities, is groundbreaking. The JWST might have found the lights we were searching for, possibly propelling us into another tremendous wave of human advancement. Most importantly, let's delve into the universe of planets and exoplanets to figure out how this was even possible. The James Webb Space Telescope's mission explores Proxima B and its secrets. Since the dawn of time, humans have wondered about the nature of the universe. Who are we? Where do we come from? Where do we go? These are ordinary yet incredibly difficult questions that humanity has strived to answer since we gained self-awareness. In this era of great technological advancement, one wonders if we are any closer to answering these questions. A philosopher might say we are still at level 0 of understanding ourselves and the universe. However, ask a space scientist the same thing, and watch them light up with excitement as they race to tell you about the latest discovery made using their sophisticated devices. These instruments, though often overlooked by the general public, directly reflect human progress. We now have the world at our fingertips, and it's time we push forward to grasp the universe as well. One such method involves utilizing technology like the James Webb Space Telescope, a creation born from humanity's endeavors to explore space. This infrared astronomy device is already addressing these timeless questions. Proxima Centauri B, or simply Proxima B, is sometimes referred to as Alpha Centauri C. It is a super-Earth exoplanet orbiting an M-type star. Super-Earths might sound confusing, but don't worry. This text will resolve your burning questions. Super-Earths are a class of planets more massive than Earth, but lighter than ice giants like Neptune and Uranus. They can be composed of gas, rock, or a combination of both, with sizes ranging from 2 to 10 times the mass of Earth. Proxima B is a super-Earth and an exoplanet, meaning it orbits outside our solar system. The first possible evidence of an exoplanet was found as early as 1917, though it garnered little interest at the time. In 1992, the first confirmed detection amazed researchers. Another exoplanet first detected in 1988 was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of these, 896 systems have more than one planet. These discoveries revolve around M-type stars. To understand an M-type star, you need to grasp the concept of red dwarfs. Red dwarfs are the smallest type of star in the main sequence and the most common type found in the Milky Way. Their low luminosity makes them harder to detect. These stars have variable definitions and names based on their temperatures and sizes. For example, M dwarfs or M-type main sequence stars have a maximum temperature of around 3000 K. Returning to Proxima B, its mass is known to be approximately 1.07 times that of Earth. Interestingly, it only takes 11.2 days to complete one orbit of its star, compared to Earth's 365.25 days. This reflects the small size of Proxima B's host star. In terms of luminosity, the star emits just 1.6% of the Sun's total brightness and only 5 to 6% of its luminosity in visible light. Over 85% of its emitted energy is in the form of infrared radiation. Proxima B orbits its star at a distance of about 0.045 to 0.056 astronomical units (AU). Its discovery was announced in 2016, sparking immense interest in the scientific community. But why all this focus on Proxima B when there are countless stars, planets, and galaxies in the universe? There are a few reasons for the particular fascination astronomers have with this celestial body. First and foremost, Proxima B is the closest known exoplanet to our solar system. Though 4.2 light-years might seem like an enormous distance to us Earthlings, in the grand scale of the universe, it is a mere blip. Its proximity alone makes it a top priority for research. Moreover, Proxima B is part of the Alpha Centauri triple star system, which has long been a subject of astronomical interest. While Proxima Centauri itself is a faint red dwarf, the system appears as one of the brightest celestial objects in the night sky. The most intriguing aspect of Proxima B, however, is that it resides within the habitable zone of its star. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions might be just right for liquid water to exist on a planet's surface. This makes Proxima B a potential candidate for hosting life as we know it. Its unique characteristics and location have driven astronomers to investigate its secrets further, pushing the boundaries of technology and science to uncover more about this mysterious world. This is where the James Webb Space Telescope, JWST, plays a pivotal role. The JWST has been instrumental in probing Proxima B and similar exoplanets. Its four primary objectives are: 1. To search for light from the first stars and galaxies that formed after the Big Bang. 2. To study galaxy formation and evolution. 3. To understand star and planet formation. 4. To explore planetary systems and the origins of life. The advanced capabilities of the JWST make it possible to analyze the atmospheres of exoplanets, detect potential biosignatures, and even search for signs of artificial lights that might indicate the presence of intelligent life. In 2024, the JWST's higher sensitivity and expanded range allowed it to detect light anomalies on Proxima B, potentially caused by artificial sources. This discovery has led scientists to speculate about the possibility of advanced civilizations on this distant world. While further investigation is needed, the implications of such a finding are monumental, offering profound insights into the nature of life in the universe. Proxima B's unique combination of characteristics, its proximity, location in the habitable zone, and potential for supporting life, makes it a focal point for ongoing research. The James Webb Space Telescope has opened a new chapter in our understanding of the cosmos, bringing us closer than ever to answering the age-old question: are we alone in the universe? Stay tuned as we continue to explore Proxima B and the vast, uncharted territories of space, unraveling the mysteries of distant stars and planets. As we draw nearer to the climax of these missions, from searching for exoplanets to searching for extraterrestrial life, one may ask, What exactly is driving this quest? Considering that humans have always been inquisitive creatures, testing and delving into everything that moves or doesn't move, it makes sense that a mission like SETI, Search for Extraterrestrial Intelligence, would emerge on such a grand scale. Imagine that the universe has been orchestrated like a great cosmic project, but with a twist. We are entrusted with the task of scanning for signals, specifically electromagnetic whispers from civilizations beyond anything we can currently imagine. SETI, short for the Search for Extraterrestrial Intelligence, resembles the world's highest-stakes game of hide and seek, with Earth as the seeker and the vast universe as the seemingly endless hiding spot. This field, where scientists act as advanced detectives tuned into radio waves, began in earnest during the 1960s. Frank Drake, a prominent astrophysicist, was the first to design and launch a radio telescope search, proposing that the hunt for extraterrestrial life could focus on detecting artificial radio signals, possibly from advanced civilizations. A major breakthrough occurred when the first artificial signals were identified, radio transmissions from Earth itself. This discovery set the stage for significant advancements, pushing the boundaries of how we search for intelligent life. As technology continues to improve, detecting artificial lights or even electromagnetic signals from distant planets becomes increasingly feasible. The possibility that we might someday identify these subtle, extraordinary signs brings us ever closer to answering the age-old question: are we alone? With advancements in technology, instruments like the James Webb Space Telescope, JWST, and the forthcoming Extremely Large Telescope, ELT, are equipped to detect faint electromagnetic signals or artificial light emanating from exoplanets, particularly those in habitable zones. These tools capture light in various frequencies, especially infrared, where many potentially habitable planets shine. If these telescopes can detect artificial light or unusual signals from distant worlds, it could mark the beginning of a new era in astrobiology, the discovery of extraterrestrial civilizations. One of the most significant challenges we face in this search is the vastness of space. Even with our most advanced telescopes, the distances involved are staggering. For example, Proxima B is more than 4 light-years away. This means that any signals we detect today would have traveled for years before reaching us. This delay poses not only a challenge for data collection, but also for interpreting these signals. What we discover in the coming decades could be a glimpse into the distant past of another civilization, one that may no longer exist when we receive its message. The possibility of someday receiving a clear, undeniable signal from Proxima B or another exoplanet keeps researchers awake at night. Imagine for a moment what it would mean for humanity if we were to confirm the existence of intelligent life beyond our planet. The implications would be profound, not just for science, but for philosophy, religion, and our understanding of humanity's purpose. Would such a discovery alter how we view our place in the universe? Would it change our understanding of life, death, and our role on Earth? These are questions that scientists, philosophers, and dreamers have pondered for centuries. Furthermore, the detection of artificial light or signals from another world would not only represent a triumph of technology, but also a reflection of the human spirit. Our insatiable curiosity, our drive to explore the unknown, and our desire to connect with something greater than ourselves. This search for life in the universe is a deeply human endeavor, a quest to understand, discover, and belong. The coming decades will be critical in this journey. With advancements in ground-based and space-based telescopes, we are on the brink of learning more about the conditions that make planets like Proxima B habitable. Scientists are refining their search methods, using techniques like spectroscopy to analyze the atmospheres of distant exoplanets for signs of life, such as oxygen, methane, or even artificial chemicals. However, identifying life, or signs of it, on another planet doesn't rely solely on technology. It also requires us to rethink our definitions of life itself. While we typically conceive of life as carbon-based organisms, the possibility exists that alien life could be vastly different from anything we can imagine. Scientists are exploring alternative biochemistries, such as life that could thrive in extreme environments or rely on different building blocks like silicon instead of carbon. In this context, even if we detect signals from distant planets, it may take time to determine whether those signals originate from alien civilizations or are simply natural phenomena. As we continue to push the boundaries of what is possible, collaboration between global space agencies, private companies, and scientific institutions will be essential. The future of space exploration, particularly in astrobiology, requires collective effort and a willingness to embrace the unknown. Whether through the search for biosignatures, the detection of artificial light, or the decoding of potential signals, the journey to find life beyond Earth will define the next chapter of humanity. While the prospect of discovering life on another planet remains elusive, the advancements being made and the questions being raised are already transforming our understanding of the universe. The discovery of light signals, or even the faintest hint of life elsewhere, would not only be one of the greatest scientific breakthroughs in history, but would also resonate on a deeply human level. It would challenge our assumptions, redefine our place in the cosmos, and open the door to new possibilities for humanity's future. The search for extraterrestrial life is not just a scientific pursuit. It is a quest that speaks to the very core of who we are and our eternal drive to explore, understand, and connect. The search for extraterrestrial life is also a mirror reflecting our greatest strengths and vulnerabilities. It reminds us of the fragility of our existence and the immense interconnectedness of life on Earth. While the discovery of alien civilizations would undoubtedly reshape human understanding, it also raises practical, ethical, and philosophical questions. For instance, how would we respond to a confirmed extraterrestrial signal? Would we attempt to communicate? And if so, what message would we send? Humanity lacks a unified protocol for engaging with intelligent life beyond Earth. Some scientists advocate for cautious observation, while others propose an open exchange of information. Regardless, any form of contact would require unprecedented global collaboration and agreement. The implications of such a discovery extend beyond communication. How would the existence of alien civilizations influence geopolitics, religion, and culture? Would it unite humanity under a common identity, or would it deepen existing divisions? History has shown that transformative discoveries often provoke both awe and resistance, as societies struggle to integrate new paradigms into their worldviews. Furthermore, the concept of alien life challenges us to confront our biases and assumptions. We often envision extraterrestrials as humanoid, technologically advanced, and eager to communicate, but life beyond Earth could defy all our expectations. It might exist as microbial organisms in subsurface oceans, as intelligent machines evolved from artificial intelligence, or as entities entirely incomprehensible to human perception. This uncertainty underscores the importance of interdisciplinary approaches in the search for life. Astrophysics, biology, chemistry, engineering, philosophy, and even art must converge to address the multifaceted questions posed by extraterrestrial life. Such collaboration not only enhances our scientific efforts, but also enriches our understanding of humanity's place in the universe. At the same time, the pursuit of alien life holds profound implications for environmental stewardship. The study of other planets' biospheres forces us to reflect on our own. The fragility of life elsewhere emphasizes the importance of preserving Earth's ecosystems and addressing existential threats such as climate change, nuclear conflict, and resource depletion. The discovery of extraterrestrial life would be a wake-up call, a reminder that we are stewards of a unique and precious world, tasked with ensuring its survival not only for ourselves, but also as a potential beacon for others in the cosmos. As we stand on the threshold of unprecedented exploration, the possibilities are both exhilarating and humbling. The next few decades promise groundbreaking advancements in technology and methodology, bringing us closer to answering one of humanity's oldest questions. Whether we discover microbial life on a distant moon, signals from an advanced civilization, or evidence of long-extinct organisms, the journey itself is as transformative as the destination. This quest is a testament to humanity's indomitable spirit, a celebration of our curiosity, and a reflection of our longing to connect. It is a reminder that while we may feel small in the vastness of the cosmos, our ability to wonder, explore, and create meaning is profoundly significant. The search for extraterrestrial life is not merely a scientific endeavor. It is a story of hope, unity, and the boundless potential of the human spirit. It is a journey that reaffirms our shared humanity and our enduring drive to understand our place in the universe. And so, we continue to look up at the stars, sending out signals and searching for whispers in the cosmic dark, knowing that what we find, or fail to find, will forever shape the narrative of who we are.